चलो, so variable force का some more JEE mains questions will do. करो. The force I given as minus xi cap plus yj cap. The particle is moved from a point 1, 0 to 0, 1. A to B is moving. The work done by the force is how much? Work done by the force. Since it's a variable force, work देखो force is depending on x, right? X and y. What is the work done का formula is? Integral f dot dr. Now use करो and solve.
So is that xi cap plus yj cap or minus?
Xi minus xi cap plus yj cap. So f value they given as minus xi cap plus yj cap. Options I'll give.
Sir, I got 1.
इतना फास्ट आ गया. देखो आंसर. देखते हैं. 2020 JEE Mains. dr कैसे लेंगे? ऑलवेज dxi cap plus dyj cap. Yes, one is answer. One is answer. है आपको?
या सर.
तो डॉट प्रोवाइड करने से क्या आएगा? माइनस एक्स डी एक्स प्लस वाई डी वाई एंड फ्रॉम वे टू वेयर वी हैव टू इंटीग्रेट 1 to 0 x में एंड 0 to 1 है y में. इंटीग्रेट क्या था? आ जाएगा. चलो, वन यू गॉट. यस. नेक्स्ट. A force acts on a body of mass 5 kg and displaces it from 2 to 4. What is the work done by the force? A भी variable force है.
Wait, so for the previous question, will 0 be the upper limit or lower limit?
No, initial point is A to B is going, right? So 1 to 0, lower limit to upper limit.
Okay.
0 to 1 is the y ka, 0 to 1 is lower limit to upper limit. So initial point where, final point where, that is the we should take lower limit. In numerical base 2024 का. हाँ देखते हैं.
Sir, I'm getting 54.
54 joules. हाँ. Sure, 2024 numerical based है. So since it is going in only x direction, you put x only, dx. And integration limits are from 2 to 4. What done formula is integral f dot dx. So both are the same direction, f dx only. So कितना होगा? 3x square minus 2x plus 5 times dx. Now integrate separately and put the limit 2 to 4. Answer on Krisha. Try करो. 2024 question. Yeah, good evening, Jyotish. Why late?
Sir,
What
I
done
have
by
cold. I went to hospital, sir.
oh, okay. So what done by variable
Sir, I
force
am
का
getting
result
54.
54 हाँ.
Yeah.
देखते. Mana will tell.
So 54 is wrong or right?
3x square plus 2x. Okay. ये minus 5 ले लो.
Sir,
Minus 5. हाँ, how much?
sir, wait, sir, I'm doing sir.
Yeah, the Jyotish on the video and too. We're doing work done by variable force ka we are doing.
You get 34.
Sir, 34.
34. Hey,
Yeah,
wrong.
Sir, 34 only, sir.
3x square plus 2x minus 5, right?
yeah,
2 to 4
Minus
limit.
2x.
Oh no, 3x square minus 2x minus 5, right?
yeah.
So क्या होगा? Integration क्या होगा? 3 times
X
of
cube minus x square
x
minus
cube by
5x.
3 minus 2 times of x square by 2. 5 का क्या लिया?
Minus 5x.
Sorry,
Sir,
minus
minus
5x,
5x.
right?
Yeah.
Limits are from 2 to 4, right?
Yeah,
So 3 cancel. कितना 4 cube is how much?
64.
64 minus 8. ठीक है. Minus 2 to cancel. Again 2 to 4. Limits is 16 minus 4.
Yeah,
Minus 5 times of 2 to 4. 4 minus 2 is 2.
yeah.
So कितना होगा? 64 minus 8 is 56.
56.
Minus 12.
20.
Minus
20,
10.
right? How 12?
16 minus 4 is 12, right?
Oh, yeah.
Minus 10. So कितना होगा? Minus
Yeah. 6 minus
44.
22, right? So 34 only.
Minus 22 is 34.
34.
Oh, again this also mistake. चलो, this is something, right? ये JEE Mains question में सब mistakes है. चलो, next. 23. Numerical based only.
Sir, I'm getting 30 joules.
Yes, correct.
Sir, why are they giving mass?
Why is it time pass के लिए? Because directly if their own concept again they'll go for Newton's second law something जाएगा ना.
So I got 30.
Yes, 30 joules. They got 23, 24. Easy there. It's not. Chalo. Now, okay. You also got a no? Results.
That's a 30, right?
Yeah, 30 joules is answer. Now we'll go for conservative, non-conservative force. Jyotish on the video. Conservative force and non-conservative force. So see, abhi tak we started work done when the force is constant, and work done when force is variable also be done. That's it till now. That only numericals be done. Now next topic is conservative, non-conservative force. Conservative force means what is meaning of conservative force? If the force is conservative, if the work done by the path is, tell me, independent or dependent?
Independent.
Independent of the path. Likho. The forces in which work is path independent is called conservative force. Okay. And conservative force ka, if the particle or object is displayed from position A to position B, suppose मान लो position A से position B तक particle got displaced in the first path, second path and third path. In सभी का work done अगर equal हुआ तो, then this force nothing but conservative force. When the path independent, this is very useful. ये separate formula नहीं रहेगा, ये formula नहीं है. But in the numericals में, they will wantedly they will give. Suppose they will put steps like this, something steps लगाएगा ऐसा. I want to bring the object from here to here. एक mass है मैं. I want to bring from here to here. So instead of taking this path, I can take this from here to here and here to here. If the force is conservative force, because path is independent, right? We can take anywhere, but initial position, final position should be same. Such type of force is called conservative force. A path independent है. कोई भी direction जाओ, work done is same. Examples, conservative force का examples are?
So but they'll mention in question, right, that the work
Did not
is
mention
equal.
in question. आपको some only 3 forces are conservative forces. Only 3 for total your portion में.
Gravitational, spring, electrostatic.
Electrostatic force. खत्म. These only 3 are conservative force. Electrostatic force, gravitation force, and spring force. So whenever when you're finding the work done by gravitation force, you can take the shortest, मतलब कोई भी path ले सकते हैं easily. Whichever easy path, that path you take, you find the work done that is same as that of the different path. We will prove also. We'll prove one example लेके we'll prove gravitation force is conservative force or not. Okay, Kapil? ज्योतिष अंडरस्टैंडिंग का कंजर्वेटिव फोर्स समझ में आ रहा है ना? हाँ चलो. Now, prove that gravitation force is conservative force. Take one example. Any example you take in the numericals में आएगा. There is no formula इसमें. Suppose मान लो this is inclined plane. Okay, angle theta है. इधर object is there. M है. I want to bring from object from here to here. Okay. Through this path A, B, C, L called. इसका length है L. Now tell me, what is the work done to bring the mass M? What is the work done by gravitational force to bring the mass M from A to C? Tell me. Work done by mg force, I'm telling. To bring the mass from A to C.
mg cos theta into L.
Mg cos theta into L. No wrong.
So won't be minus mgl sin theta.
Because पीछे क्या act होगा? mg sin theta, right? When force and displacement are in opposite direction, what is the work done is negative. So minus mgl sin theta, right? This is a force into displacement, right? Work done. Force into displacement is nothing but work done. So take care. Now,
Sir, but they're asking with gravity, right? Isn't gravity mg cos theta?
नहीं, gravity, these are mg ka only, gravitational force ka work done only. Mg is always we should take the components, right? We should not take mg again. mg ka sin theta, mg ka cos theta, right? So mg sin theta, I want to bring the charge from mass from here to here, right? Which force is acting? Only one force acting. इस तरफ वाला mg sin theta. Okay. Now same mass ko, you tell me, I want to bring the mass not this path. I will bring from here to here, then here to here. This is the first path. I will go from this path now. Now I want to calculate A to B wala plus work done by mg from B to C wala. Tell work done by mg from A to B. Tell me kitna work done hoga? When the mass is here, work done by gravitational force. Mg is like this and displacement is like this. Angle is how much?
0, right?
Zero.
Won't be 90 degrees.
Cos 90 is 0. So work done by this is 0. Okay. Now iska work done from when the mass came up to here. Now what is the force acting mg downwards and displacement is इस तरफ कितना होगा? Tell me. L का इस तरफ component is L cos theta, इस तरफ component is L sin theta. So this is displacement is L sin theta. Now tell me, force and displacement are in opposite direction. Work done is negative. So minus mgl sin theta. देखो ये वाला सेम, वर्क डन इज सेम. आप ऐसा जाओ और ऐसा जाओ, mg force का वर्क डन इज सेम. दैट्स व्हाई mg इज नथिंग बट ग्रेविटेशनल फोर्स, नथिंग बट कंजर्वेटिव फोर्स. ग्रेविटेशनल फोर्स कभी भी कंजर्वेटिव फोर्स है. एग्जांपल ले रहे हैं. ओके, अंडरस्टूड? यस. नेक्स्ट, इन कंजर्वेटिव फोर्स में वर्क डन बाय कंजर्वेटिव फोर्स इन ए क्लोज्ड पाथ इज ऑलवेज जीरो. Closed path में work done is always 0. Okay. Example, you tell me, I want to bring the suppose building है, एक mass m है, एक height h है. Okay. I want to bring the object from here to here, A to B. Tell me how much work is done?
mgh
नहीं, साइन कन्वेंशन भूल जा रहे हो.
minus mg.
Downwards is mg, ऊपर displacement is like this. So minus mgh. तो सेम मास m को वो ऊपर से नीचे लेके आने का. सो व्हाट इज द वर्क डन फ्रॉम दिस इज A to B. I want from B to A. Tell me. Same mass m को I want to bring from top to bottom. What is the downwards is mg and displacement is also same direction. What is work done is mgh. So
Yeah.
total work done is how much?
0.
So in a closed path, matlab here to here and again came back to here, same position mein. Work done in a closed path is 0 only when F is conservative force. Very important. If F is not conservative force, work done in a closed path is not 0. आप सोचेगा वर्क डन इन क्लोज पाथ कभी भी 0 हो सकते हैं, डिस्प्लेसमेंट 0 है, ऐसा नहीं है. इफ आई टेक द एग्जांपल ऑफ फ्रिक्शन फोर्स, वो 0 नहीं होगा. वर्क डन इज नॉट 0, राइट? चलो हो गया.
Sir, 1 minute.
या they in the school में they talked about if the force is given how to find whether it is a conservative force or not बोल के दिया. They told
So the differentiation thing.
differentiation thing बोला.
No, sir, I don't think so.
Okay.
So
वो
they thought
advanced
it,
में
but
है. हाँ?
so they thought it, but I forgot it.
Okay, okay. चलो जल्दी करो काम. वर्क प्रो जी बोल रहे हैं वी हैव टू फिनिश.
Sir, once can you show the previous one?
Okay, चलो. No,
Sir, can
now
you show the
conservative force.
previous one?
अरे अभी तक कितना स्लो में लिख रहा है.
Okay, sir.
Then चलो. तो नॉन कंजर्वेटिव फोर्स का एग्जैक्टली उल्टा क्या होगा? वो क्लोज्ड पाथ में वर्क डन इज 0 मींस नो, दीज आर पाथ डिपेंडेंट. एग्जांपल इज फ्रिक्शन फोर्स. खलास देखो, वर्क डन इज पाथ डिपेंडेंट, मतलब कोई भी पाथ में डिफरेंट पाथ में वर्क डन इज डिफरेंट. दिस इज नॉन कंजर्वेटिव फोर्स का. एन एग्जांपल इज फ्रिक्शन फोर्स, विस्कस फोर्स, दिस ऑल कम्स अंडर नॉन कंजर्वेटिव फोर्स का. देखो okay. Now here in a closed path में work done is not 0. In a closed path में work done is not 0. लिखो, लिखते जो नोट्स इंपॉर्टेंट है. सी अभी याद रहेगा पूरा. आफ्टर सम चैप्टर्स के बाद सेकंड ईयर में when you want to refer that time you cannot read material, you cannot do all the questions, time नहीं मिलेगा आपको. बेटर शॉर्ट फॉर्म में नोट्स में लिखो, दैट विल हेल्प यू लास्ट में. जस्ट इफ यू स्पेयर फॉर लाइक 1 वीक में पूरा फर्स्ट ईयर पूरा हो जाएगा. आप इफ यू नोट्स है तो ओके. चलो सपोज एग्जांपल टेल मी. सपोज मान लो हियर मास m is there.
You'll get the same value.
हाँ,
Like if you make it slide this side or slide that side, the work done will
वर्क
be the
डन इज सेम. देखो when the mass m I am moving from here to here, friction force is acting like this. So what is the work done here? Tell me. Work done to bring the object from A to B is force
Minus
instead of
mu mg
minus fs.
is
F friction का I'm telling. But done by friction I'm calculating. Minus fs. Same thing if I want to bring the mass m from here to here. This will this. So क्या होगा? This is B, this is A, right? I want to bring the mass from
minus
B to A.
FS.
Again minus fs. Because
Yeah.
friction is acting in the opposite direction. Now add करो total work done is not 0. Total work done is not equal to 0. That's why it is called non-conservative force. Friction देखो, इधर से आप लैंको हिल्स मानिकोंडा से जाओ, and suppose you are going from some गच्चीबोली से किधर घूम के आ रहे हैं, friction different है ना, so work done is different. Okay, so that's why it is a non-conservative force का कभी भी work done is not equal to 0 in a closed path में. चलो now differences understood, already no need of writing. देखो path independent, path dependent है, closed path में 0 है, closed path is not 0. देखो पोटेंशियल एनर्जी इज डिफाइंड फॉर ओनली फॉर कंजर्वेटिव फोर्स, याद रखो पोटेंशियल एनर्जी इज डिफाइंड ओनली फॉर कंजर्वेटिव फोर्स, नॉन कंजर्वेटिव फोर्स का पोटेंशियल एनर्जी नहीं है। कभी भी देखा फ्रिक्शन एनर्जी, फ्रिक्शन का पोटेंशियल एनर्जी बोले तो नहीं रहेगा, ओनली कंजर्वेटिव फोर्स का mgh बोल के सब कुछ कंजर्वेटिव फोर्स का रहेगा, स्प्रिंग पोटेंशियल एनर्जी रहेगा, बट फ्रिक्शन पोटेंशियल एनर्जी नहीं है। ओके, एग्जांपल्स ऑलरेडी यू नो, इलेक्ट्रोस्टैटिक फोर्स एंड इधर फ्रिक्शन फोर्स एंड विस्कस फोर्स। विस्कस फोर्स आपको मैकेनिकल प्रॉपर्टीज ऑफ फ्लूइड्स में आएगा, विस्कोसिटी बोल के, वही है ना, यू नो हनी इज मोर विस्कस, लिक्विड ज्यादा, फ्रिक्शन ज्यादा है। ओके, ओके, एक छोटा सा कॉन्सेप्ट देके देन ओनली वी आर एंटर इनटू द एनर्जी में एंटर होने वाला, बट इसका क्वेश्चंस करेंगे सब कुछ। इंपॉर्टेंट पॉइंट्स पूरा लिख लो मानो, notes should be.
So for this I only wrote about the potential.
So there's no potential energy for unconservative force.
No potential energy. लास्ट में कैसे करेगा, व्हेन एवर 1-2 मंथ्स ओनली इज देयर एग्जाम टाइम में, जेई मेंस में टाइम आपको नोट्स निकाल के 1 वीक में फर्स्ट ईयर, 1 वीक में सेकंड ईयर, यू नोट्स रफ बुक में लेके प्रिपेयर कर लो, देन पेपर्स करने के, फुल पेपर्स करेंगे। बट ज्योतिष अंडरस्टैंडिंग एनी डाउट्स?
Understanding, sir.
डाउट है तो पूछो, डोंट बी शाई। ओके, तो कैसे वीडियोस भी है वेबसाइट में है ना, वीडियोस यू कैन लिसन 1 सेकेंड, कभी भी यू नो एक बार नोट्स में लिखे तो फिर से लिसन करो, 2-3 बार तो समझ में आ जाएगा आपको। ओके, चलो, कॉपीड कॉपीड कॉपीड। हाँ, चलो ना न्यूमेरिकल्स करेंगे तो समझ में आएगा। चलो, सपोज ए 4 kg particle is there, moves from origin to C, इधर से इधर, one I took this path, one I took this path, one I took this path, red path, blue path and purple path. He's telling in all case में try to find the gravitational force का work done, he's telling to find work done by gravitational force, easy है ना, कितना kg है, 4 kg mass, कैलकुलेट करो।
So can't we directly find displacement instead of taking the path?
which path
Hold
you
on.
want to,
They mentioned it.
any path you can take, but see since gravitational force is a you know
No, it's
conservative
conservative.
force, right? So one path को find करो, खत्म।
So I want to get root 2 in the answer.
What?
So I'm getting 200 root 2.
200 root 2, wrong. Which path you choosing? Tell me first. OAC, yeah?
OC.
OAC, right? OC nahi hai. We have to reach to the C finally. Okay. From here to here we have to reach. Which path will go first?
So
So
over
any
here,
path will be the same now, sir.
Any path will be same, but you want
just
which
be
path?
200.
Sir, I took OC.
200 is answer. It is minus 200 is answer.
Yeah.
You choose which path I'm asking, Krishna. You choose here like this or like this or like this.
So OC.
OC you choose, है ना? हाँ,
Yeah.
tell me OC में what the displacement is how much?
5 root
देखो
2.
mg is like this, displacement is like this, right? So angle between them is how much? Angle is how much? This is 45, this is 90, so this is total is 135. So what done is fs cos 135.
Okay.
Cos 135 you can know how to find, right? 90 plus 45 करके, How much you got, Pranav?
Sir, I can't see the coordinates properly.
Coordinates are 5, 5. This is origin. That's it. Do we coordinates? कितना है कृष्णा आंसर? -200 you
Sir,
got?
-200.
Yes, -200 is the answer. So देखो force work done by 4 kg वाला is कितना? mg into displacement. How much displacement is?
5.
ये वाला. And इसका cos
Cos
if
130.
y 5 ये वाला कितना है? This is 5, right? This is 5. This will be 5√2, right? I am trying to find this one. This one.
Yeah,
Okay,
5√2.
mg s into cos 135. So mg means 40 into 5√2 into cos 135 is -1/√2. Cancel. So it is -200 joules. Yeah, but done by 100 was. Okay. One small JEE question, that theoretical, I think so. Try karo. JEE mains question. A body of mass 50 kg, a 50 kg है, a mass है, a भी 50 kg है, mass है. Okay, lifted from a height 20 meters from the ground in 2 different ways. First case में he lifted from here to here. Second case में he lifted through ramp के साथ ऊपर लेक तक ले गया. Okay. I shown in figure the ratio of work done against the gravity in both respective cases.
So what's theta?
Theta is
What's theta and
30 degrees. Both of them is 30. And h is 20. Question I should write. I took from ramp. One I should directly I lifted from here to here. Then he's asking what is the ratio of the work done by the in both the cases.
So won't it just be 1:1?
देखिए क्या है.
yes, so 1:1.
Yes, 1:1 is answer. Because gravitational force
Gravity, right?
का ग्रेविटेशन फोर्स का कंजर्वेटिव फोर्स है. आप इधर से हाइट देखो, दोनों में सेम देखो. हाइट इज 20, वर्टिकल हाइट इज सेम. आप कैसा भी करो, कोई भी पाथ में जाओ, बट आपको फाइनली यू आर रीचिंग फ्रॉम हियर टू हियर, राइट? हियर इधर रीच हो रहे ना ऊपर, बट सिंस बोथ द वर्टिकल हाइट्स आर सेम, द वर्क डन इज सेम इन बोथ द केस, सिंस ग्रेविटेशन फोर्स इज ए कंजर्वेटिव फोर्स. सो W1 is to
Sir, but
W2.
for that you told that they have to start from the same position and they have to end in
Initial
the same
point and same point is same, okay, but if you calculate also, if you solve, you will get the same thing. If you normal method से solve करो, work done is same, because gravitational force का work done इसमें देखो, one condition is initial point and final point should be same. Initial point and final point should be same. Okay, so देखो from here to here, see, मान लो this block is there. Before I done numerical, right? One method is I brought from here to here. That is one first case. Second case में क्या है? I will bring from here to here and then from here to here. From here to here, work done is 0, right?
0.
कुछ काम नहीं. So 1:1 ratio is answer. ये वाला 2024 में आया.
Sir, I have a doubt, sir.
Tell me.
So in the first case, when covering only the height, the work done will be minus mgh, right?
Force and displacement in the opposite. Displacement is how much?
H.
H कैसे है? H is 20. Yes, correct only. So minus mgh, yeah.
So and then second case will be minus mg sin theta into h cos theta.
इसका क्या है? इसका डिस्प्लेसमेंट कितना होगा?
40
देखो,
by root 2.
if you take the sin theta, sin 30 is equal to opposite by hypotenuse. Hypotenuse L मान लो. So L is how much? 1/2, right?
Yeah.
L is equal to 2h, right? मतलब 40.
40, yeah.
तो ऐसे कर देते तो सेम आएगा. ओके, चलो नो. सो लिखो, kinetic energy is the capacity of the body to do work by virtue of its motion. When the work object is in motion, it has kinetic energy, and kinetic energy का famous formula है half mv square, half mv square. And whether kinetic energy depends on frame of reference? Yes or
Yeah.
no? Yes, it depends on frame of reference. Okay. Stop it. Half mv square. Mano on the video. चलो. Next. देखो kinetic energy depends on frame of reference. मान लो
What
suppose
is the definition?
huh?
The virtue of a body of motion.
Motion is called as kinetic energy. And kinetic energy formula is half mv square. लिख दिया? Now here देखो kinetic energy depends on frame of reference. Suppose बस है, बस में A person is there, C person is there, B person is there. He is standing on the ground. According to B, what is the kinetic energy of the C value? C कितना है? Of C with B. How much kinetic energy is? He is moving, right? According to B, the person is moving with some velocity. So half mv square, right? Now according to A, what is the kinetic energy of the person?
0.
According to A, C according to A. Okay, A के respect में what is the kinetic energy of the C person is 0. That means it depends on frame of reference. And you know what is the relation between kinetic energy and momentum?
P square by 2m.
Very good. P square by 2m is a formula for kinetic energy and momentum. Very important. इसी में so many questions are there. JEE mains questions we are doing now. Okay, P square by 2m. From this, P is equal to under root 2mk. Right? So sometimes that relation, inverse relation you can find by this. चलो solve करेंगे kinetic energy का. Momentum formula मालूम है ना? Momentum is mass times of velocity. चलो. हाँ. करो. JEE mains questions एक एक आंसर से बोलते जाओ. Easy है, ट्राई करो. The next topic only work for energy.
So Ke is equal to P square by 2m, right?
P square by 2m.
Okay.
They have same momentum, the ratio of their masses. Kinetic energies are given.
9:16.
Khatam. They're inverse relation, right? So kinetic energy is equal to P square by 2m. Relationship क्या है? Kinetic energy and same momentum है ना? Kinetic energy is inversely proportional to mass. So kinetic energy का उल्टा लगाने का. So kinetic energy 16:9. It will be 9:16. आया? Pranav, you got?
Yes, sir.
So I can write like this if you want. Ke1 by Ke2 is equal to m2 by m1. So m2 by m1 will be Ke1 by Ke2 is nothing but 16:9, right? So 16:9. So therefore m1 by m2 is ratio is how much? m2 is equal to 9:16. Steps पे लिख सकते हैं. Okay. So next one. Any options? Two 23.
Sir, highest point of fight or flight?
Sir, 4
highest
is to
point of
3.
flight will be
4 is to 3.
4:3. Yes, correct. Perfect. Very good.
Sir, may I have a 4:3?
4:3 only. Yes. See, proton motion ka.
So it will be u cos theta at highest point.
Highest point mein what is the velocity? U cos theta.
Yeah.
So half m into v square means u cos theta whole square. Theta you know already 30 degrees.
Yeah.
So that kinetic energy will get, and initial kinetic energy is half mv square, right? Half mu square. Divide karo. The means questions if we can do it is easy now. We will get everything. And work per energy आता है? Krishna? Work per energy theorem. Work energy theorem. अरे, you'll always tell.
Sir, but if I solve, I'm getting 3:1.
Why 3:1? Kinetic energy, initial kinetic energy is how much? Half mu square.
U square, yeah.
इसका if you solve कितना आ रहा है? If you second one kinetic energy का half mu square.
Half. Oh, no, mind, sir. I wrote it as 8 by mistake.
So 4:3 will be coming with the answer.
Yeah, 4:3. Yeah, I got it.
Yes. Next. A body of mass this much, another body of mass this much, with equal kinetic energy. The ratio of their momentum is how much?
2:8.
Options I'll give.
I think I can do.
2022.
Let me do, sir.
Sir,
So
4
1 is
is
to
to
4.
1.
Sir, once again.
एक कर रहे आराम से करो.
Sir, I'm getting 4 is to 1.
I don't know. I'll check.
Sir, it's 2:1.
Yes, perfect. Is the answer. 2:1 is
E
answer.
square will be 4:1.
देखो kinetic energy p square by 2m, right? So kinetic energy is same बोले ना. So p is equal to under root 2m k, right? So that means since kinetic energy is same, 2 is same, everything is same. So p1 by p2 or p2 by p1
Sir, 2
is
is to 1
equal
is
to
the same thing as 4 is to 1. Sir.
2:1 same as 4:1.
They're like squaring on both. Sir. Something like that.
So answer is 2:1 is the answer. Pranav, you got answer?
Yes, sir.
So directly if you solve under root 8 by 2, 2:1. So next one. See, percentage change means क्या करेंगे generally? Percentage change or
Change divided by original into 100.
Yes, very good. Change by original to 100.
So can I know options once? Oh. 84. Sir,
Sir, I
84%.
Yes, 84%. 2024. Initial velocity also given. Final velocity also given. Percentage change. Change by original to 100.
Sir, I'm getting 40, sir.
Kinetic energy final by kinetic energy initial into 100, right? कितना half m u square is 100 square minus half कितना half m into 40 square by half m into 100 square into 100. So cancel half m कितना सॉल्व करो, कितना आएगा? So 1 2 3 4 minus 1600 by 1 2 3 4 into 100. Solve किया तो you'll get 84%. Okay, change by original into 100 is the formula. Always we have to follow that one. Okay, next.
Sir, one. Huh? Yeah, one on option D.
देखिए 2021
What is the speed of? Yeah, the does change, right? Yeah, one only. So what is option A?
19.
Sir,
So
it's
I'm getting
option C.
4.47.
देखेंगे
Sir, I'm
कौन सी
getting
बात?
root 20.
root 20
Yeah,
means
sir,
approximate.
4.47.
Yes, this is answer. Perfect answers.
Oh, it's V square.
Who told to do c square is क्या होगा, 4 square तो क्या
Still, sir, I'll get one only.
होगा? So easy, right? आपको देखो he
Oh,
only
V
told
square.
initial kinetic energy find करो
Sir,
half
I
mv
forgot V
square.
square.
हाँ, and उसमें 5% of the initial kinetic energy तो आपको final kinetic energy जाएगा, then speed half mv square लगाए तो you'll get the answer. This is answer. 4.47. So now करो perfect करो, देखते हैं will do. 2021. I was asking percentage change in momentum.
So the masses are same, right?
Kinetic energy of moving body. Yeah. Mass is same.
So the momentum becomes double. You'll have
I want percentage.
200%.
Okay, I'll give options.
For percentage change is 100, sir.
देखेंगे.
Yeah, percentage change is 100, but it's 200% increase.
So final answer yours is how much, Pano?
100.
Yes, 100 is right. See, kinetic energy is equal to p square by 2m. So you told kinetic energy and momentum, correct? So Ke1 by Ke2 is equal to P1 square by P2 square, or P1 by P2 whole square. Now you try to find kinetic energy initially is how much? Kinetic energy of the moving body becomes 4 times that of the initial kinetic energy. So Ke2 will be 4 times of Ke, right? So Ke cancels 1 by 4 आएगा. P1 by P2 whole square. So therefore root है तो 1 by 2 आएगा. So P2 is equal to 2 times of P1. Now he's asking percentage change in momentum. So change बोलते क्या है? Change by original into 100. So कितना होगा? पिछला कितना है आंसर?
Sir, I'm
Percentage
getting
change
minus 50, sir.
P1 into 100. Right? Percentage change means final minus initial. कितना है? That is 2P1 minus P1 is P1 by P1 into 100, which is 100%. 50 तो नहीं है ना ऑप्शन? है समझ में? चलो, वर्क एनर्जी थ्योरम करेंगे थोड़ा. एनर्जी है ना, वर्क एनर्जी थ्योरम. चलो, व्हाट इज वर्क एनर्जी थ्योरम अकॉर्डिंग टू यू?
Sir, the total work acting on a body is equal to change in kinetic energy.
Yes. So work energy theorem says work done by all forces, कंजर्वेटिव होने दो, नॉन कंजर्वेटिव होने दो, सब कुछ all forces का work done is always is equal to change in kinetic energy. Work done is equal to change in kinetic energy, that is K final minus K initial. See आपको क्या है, whenever the question में they ask work done, हम लोग कभी भी किधर किधर स्टक हो जाएगा? वेर इज फोर्स, वेर इज डिस्प्लेसमेंट, एफ डॉट आ रहा, एफ डॉट डी आ रहा, कैसा क्या यूज करेंगे बोल के देखता जाएगा. बट आपको वर्क डन पूछेगा, बट दे विल गिव वेलोसिटी एंड मास. यू हैव टू यूज द काइनेटिक एनर्जी. फोर्सफुली लगाना पड़ेगा आपको, फोर्सफुली आपको लगाना पड़ेगा चेंजिंग काइनेटिक एनर्जी, देन ओनली विल गेट वर्क डन, बिकॉज दे विल नॉट गिव द फोर्स, दे विल नॉट गिव डिस्प्लेसमेंट. स्टिल वी कैन फाइंड बाय यूजिंग दिस फॉर्मूला. दैट्स व्हाई वर्क एनर्जी थ्योरम इज वेरी यूजफुल फॉर फाइंडिंग वर्क डन बाय अ फोर्स whose exact nature is not known. वो मतलब एग्जैक्ट नेचर इज नॉट नोन मींस उसका डिस्प्लेसमेंट नहीं मालूम, समटाइम्स फोर्स नहीं मालूम, बट इवन देन वी कैन कैलकुलेट द वर्क डन बाय यूजिंग दिस फॉर्मूला. ओके, और फाइंड द वर्क डन बाय वेरिएबल फोर्स हुज एग्जैक्ट वेरिएशंस इज नॉट नोन. सो एग्जैक्ट वेरिएशन मतलब कैसा किस तरफ जा रहा है बोल के वी डोंट नो, देन आल्सो वी कैन फाइंड बाय यूजिंग दिस फॉर्मूला. सो व्हाट इज द फॉर्मूला? वर्क डन बाय all forces is equal to change in kinetic energy. This is the formula. Work done by all forces means क्या क्या फोर्स आएगा टेल में? Work done by all forces means work done by conservative force, मतलब all forces. Work done by non-conservative force, work done by internal forces, work done by external forces, and work done by pseudo force also. If you add pseudo force also, if you add everything is equal to final kinetic energy minus initial kinetic energy. If you miss any work done का कलस आंसर रॉन्ग हो जाएगा. If you miss any work done का आंसर रॉन्ग. ये वर्क डन कौन सा? पार्टिकल के ऊपर जो फोर्स लग रहा है ना उसका वर्क डन. आई एम टेलिंग वर्क डन बाय ऑल फोर्सेस इज इक्वल टू चेंज इन काइनेटिक एनर्जी. खत्म, यही फॉर्मूला सेट वर्क एनर्जी थ्योरम. वर्क एंड एनर्जी का रिलेशन देखो, एनर्जी इज दिस वन, वर्क का वर्क एनर्जी थ्योरम. यू नो आईपी में दिस चैप्टर वर्क एनर्जी थ्योरम ओनली, वर्क एनर्जी ओनली 8 मार्क क्वेश्चन विल बी देयर. आईपी में आपको क्या रहेगा? आपको सेक्शन ए, सेक्शन बी, सेक्शन सी रहेगा. सेक्शन सी में 3 क्वेश्चंस विल बी गिवन. आउट ऑफ 3 यू हैव टू राइट 2 क्वेश्चंस. स्टैंडर्ड है. विच चैप्टर विल बी कमिंग दैट वन? 2 क्वेश्चंस में वन इज वर्क फॉर एनर्जी आएगा, अदर इज ऑसिलेशन चैप्टर आएगा. ओके, एंड थर्मोडायनामिक्स आएगा. थर्ड क्वेश्चन विल बी थर्मोडायनामिक्स. थर्मोडायनामिक्स को पकड़ने की जरूरत नहीं है बिकॉज ऑप्शंस है ना, आपको 2 ही क्वेश्चन पढ़ने का, ऑसिलेशंस एंड वर्क फॉर एनर्जी. चलो हो गया. So
Yeah.
you know, tell me.
No sir, हो गया. Yeah.
Finished. चलो. इसका न्यूमेरिकल्स करेंगे. you know how to find work done and you know how to find kinetic energy. So दोनों मिक्स करके सॉल्व करने वाला है. ओके नेक्स्ट. हाँ न्यूमेरिकल्स करेंगे. हाँ करो, एक क्वेश्चन करो देखते हैं. A body of mass this much travels along a straight path with velocity is given in terms of displacement. Okay. Net work done by the force during a displacement of 0 to 2 meters. I want work done. Find karo.
So 3 joules.
Three.
Yeah. Oh, never mind, never mind. I'm always thinking it's half mv instead of half mv square.
The body of mass travels along a straight path with velocity in terms of displacement. देखो velocity mass is given, velocity is given. He's telling to find work done. So work energy theorem use karo. Work done is equal
So we
to.
can just find acceleration and find force, right?
But try to use the work energy. वो भी आदत कर लो. Final kinetic energy minus initial kinetic energy. Final kinetic energy is half mv square. Final velocity is how much? Well, if I substitute x equal 2 in
60,
this,
60, 60.
So answer is
60.
yes, 60 joules. देखो half m v square minus half m u square. Okay, v square means v final कितना v कितना होगा? x equal 2 लगाओ, इसमें कितना होगा? 3 into 4 plus 4. So 12 plus 4, 16. And initial velocity is how much? When you substitute x equal 0, you'll get initial velocity. So 0 plus 4 is 4. So now substitute here. Half m common. V square means 16 square is 256 minus u square is 16. So कितना होगा? 40. So half into m is 0.5 into
60 I got.
40. So 120, 60. So देखो वर्क एनर्जी थ्योरम यूज करके करना पड़ेगा. सी एग्जाम में आपको व्हेन यू आर गोइंग यू ऑलवेज कीप इन माइंड दैट वर्क एनर्जी थ्योरम एक कॉन्सेप्ट है बोल के. नहीं तो ऑलवेज वर्क डन पूछे तो अरे फोर्स डिस्प्लेसमेंट एक्सेलरेशन उसी में मत जाओ, फंसो मत फंसो. ओके चलो करो. यही मेरे क्वेश्चंस करो अच्छे से. The particle experience a force is given. Assume distance meters, okay, newtons. A particle moves from this point to this point in xy plane. He is asking kinetic energy change. But indirectly we have to find work done. Plus variable force का work done, you know, right? Find करो.
Yes, sir. This is easy, sir. So direct question is this.
Yeah, that question. 2022 में आया.
So 25.
देखेंगे.
Yeah, so 25.
Yeah, 25
Also
answer.
25.
Next. a body of mass m drop from a height h reaches the ground with a speed इतना speed से नीचे गिर रहे हैं अंडर रूट जी एच वाला ओके 0.8 अंडर रूट जी एच रूट में है पूरा दोनों द वैल्यू ऑफ वर्क डन बाय द एयर फ्रिक्शन when the object is falling air friction is acting now देखो he is telling to calculate the work done by air friction इसका force दिया है we don't know air friction का force नहीं मालूम displacement तो h है ठीक है but force नहीं मालूम but even though force नहीं मालूम we can find the work done wall is mass from a height h drop from a height h
So this is
इसका
the velocity is 0.8 root gh, right?
Sir, I got
हाँ 0.5
minus,
root
sir, I got minus 136 mgh by 200.
yeah I'll give options minus 0.68 mgh mgh 1.64 mgh
So minus 0.68.
देखते हैं वो लोग भी करने दो
Sir, it's minus 0.68.
देखो कृष्ण व्हाट आर द फोर्सेस एक्टिंग ऑन इट वर्क डन इसके ऊपर व्हेन इट इज फॉलिंग आपको दो फोर्स एक्ट हो रहा है वर्क डन बाय वी आर यूजिंग वर्क थ्योरम वर्क डन बाय ऑल फोर्सेस कौन सा फोर्स है वर्क डन बाय mg फोर्स प्लस वर्क डन बाय एयर फ्रिक्शन फ्रिक्शन इज एक्टिंग इन द अपोजिट डायरेक्शन राइट एयर फ्रिक्शन is equal to change in kinetic energy final kinetic energy minus initial kinetic energy work done by mg is how much downwards mg है displacement h है so mg work done by mgh is mgh only mgh plus work done by air friction is equal to final kinetic energy when it's falling down इसका velocity they given right कितना 0.8 root gh so half mv square half m v square means 0.8 into 0.8 into 0 gh right v square है ना इसका square gh वाला minus initial kinetic energy initially is dropped means initial velocity is 0 so from this try to find w air force का देखो यार gh cancel mm cancel now what done by air friction find करो so answer is correct answer 0 point minus 0.68 mgh this answer no, we cannot cancel right we have to bring this side right we cannot cancel directly हाँ क्या करो कितना आंसर how much you got ये when you bring this side आपको separate करना पड़ेगा right मतलब cancel कर सकते हैं हाँ so this much आया ये वाला so this from this we can find if you send or if substitute the values if you send this side you'll get the answer is minus 0.68
Yeah.
ना करो the kinetic energy of the particle after it travel 3 meters force and distance का graph is given he is telling what is the kinetic energy of the particle after 3 meters and starting from rest particle is starting from rest
Can you give option? Okay.
So shouldn't we just find area under the graph?
हाँ एरिया अंडर द फोर्स एंड डिस्प्लेसमेंट ग्राफ गिव्स आपको क्या आएगा वर्क डन
Work.
So
Work
can you
is
tell the area of the upper trapezium?
हाँ करो
No, sir. Can you tell the area?
एरिया ट्रेपेजियम फॉर्मूला क्या है हाफ इनटू सम ऑफ पैरेलल साइड इनटू हाइट
So what's the height is 2, right? Or is height 1?
हाइट इज 1 योर हाइट
Okay, yeah. So half into 2 plus 3 into 1. 2.5. 2.5 plus 4. 6.5. 6.5.
देखते हैं उनको भी करने दो ये तो सेम आंसर करो कुछ 6.5 आंसर. So रिलेशनशिप देखो, वर्क एंड एनर्जी का रिलेशनशिप है, फोर्सफुल लगाना पड़ेगा. ओके, मैं करो, समझ में आएगा. A mass of capital M kg is suspended with a string. Initially, is suspended with a string. The horizontal force F is required to displace it. I am applying a force F horizontally to displace it until the makes 45 degrees with the initial vertical angle 45 degrees. देखो ये ऊपर तक लेके आया, इधर तक लेके आया. कितना एंगल है? 45 degrees तक लेके आया. He's telling, and the body is displaced very, very slowly. What is meaning of very, very slowly a displaced means? Changing kinetic energy will be
0.
that one you have to remember. Whenever you displace the object very, very, very slowly, the changing kinetic energy is 0.
Sir, over here,
don't
we have to take the component and take the sign of it. Like over here, component will be mg root 2, but they set the horizontal force to dissipate it until it makes 45. So mg root 2 into 1 by root 2, right? Sine 45. So look at mg only as answer.
any method. Answer I'll give options. You try.
Sir,
NEET
mg.
question, question है? नहीं, कुछ नहीं, wrong. So it is mg into root 2 plus 1, mg root 2, mg by root 2, mg into root 2 minus 1.
Sir, mg.
So he's asking, नहीं, ऐसा नहीं, calculate करो. What is it telling to find? Tell me.
45 for.
Huh?
Sir, how do we use 45 here?
That is, first of all, what is telling to find? Tell me.
He's asking F.
What is the initial vertical direction is? So he's telling to find what? F, right? F is equal to, we are trying to find. So what we are applying the concept work energy theorem we are trying to find, right? Tell me, what done by all forces is equal to changing kinetic energy, right? Tell me, what are the forces acting on it? What done by force, which one we are
Gravity.
plus what done by
So
mg
gravity, tension,
and plus what done by tension is equal to changing kinetic energy, which is 0. So
Oh,
ये
yeah,
find
sir,
करने
look
का.
at mg into root 2 minus 1.
इधर देखो.
No, but won't tension and mg cancel each other?
देखो, टेंशन ये वाला है, mg है डाउनवर्ड्स, mg. ओके, ठीक है. नाउ टेल मी, व्हाट डन बाय टेंशन फोर्स बोलो, कितना आएगा?
0.
हाँ, एवरी पॉइंट ऑफ टाइम में व्हेन यू टेक फ्रॉम हियर टू हियर, every point of time में tension and displacement angle is 90. So the work done is 0. हाँ, now एक ही काम है, work done by mg पे तो आ जाएगा, work done by force is plus mg. Tell me, work done by mg कैसा आएगा? See, vertical height ले लो. See, from here to this is the initial position, this is the final position, right? So vertical height is how much? कितना आएगा? देखो, this is L, right? What is the L का?
L cos 45.
L cos 45. Okay, total length is L, right? मुझे A length कैसा आएगा? Tell me.
L minus L cos 45.
L minus L cos 45. This is a displacement, vertical displacement.
Yeah.
Now tell me, mg. Now mg का tell me, mg downwards and displacement ऊपर कितना आएगा? What done is how much mg का? Now
Minus mg L cos 45.
minus mg L minus L cos 45, right?
Yeah.
उधर कहते प्लस आएगा. What done by force is mg into L into 1 minus cos 45 1 by root 2.
Yeah.
So कितना होगा? आंसर कितना है?
D.
Sir, I have a doubt, sir.
1 minute. Root 2 minus 1 मरे by root 2 किधर से गया? And what done by
No,
force?
what for work of force will be
Force into A
1
भी
by
करने
root 2,
का,
right?
You tell me, what done by force कितना होगा? Tell me.
L 1 by root 2. L sin 45.
Yes. Force into displacement. Force into displacement. Displacement is how much? ये वाला
L root
L
L by root 2.
L cos L sin 45, right? So L sin 45 is equal to mg L into root 2 minus 1 by root 2. तो देखो sin 45 1 by root 2 1 by root 2 cancel. So therefore LL cancel. Therefore F is equal to mg into root 2 minus 1. Capital M, right? समझ में आ रहा है पीछे?
Sir, why is work done by tension 0?
See, always work done by tension mein, when the particle is going from here to here, always the displacement is like this and tension is like this. Angle is every time 90. Always from here to here. कभी भी displacement, कभी भी circular path में displacement of the particle ऐसा लेना, tangent लेने का, tangent. Okay, displacement of the particle is tangent. So always tension displacement is 90, work done is 0.
Yeah, sir.
आया?
Yeah.
नींद आ रहा है? लास्ट क्वेश्चन करो, हो जाएगा, निकल जाएगा. लास्ट क्वेश्चन. देखते हैं, will tell.
So do you have to find the work done by the original force or work done by friction?
I want to find changing kinetic energy of the block.
Yeah, but like
Total
with respect to
work done.
friction.
Always work done is total.
Oh, yeah, got it.
That is only work energy theorem, right? So a block of mass है 14 kg is dragged 2 meters along a horizontal surface with a force of I'm applying a force at an angle, right? 20 newtons at an angle 50 degrees. And the initial speed of the particle is initial velocity is 2 meters per second.
So sir, if I have to add the work done by the applied force and work done by friction, right?
Yes, दोनों को work done का add करो and that is equal to changing kinetic energy. That only we want.
Sir, I'm too lazy to do the calculation.
क्या करो? mg लास्ट में सब करो values. First take some mg ऐसा लेके solve last normal direction.
So normal will be 1 second 50. So normal 1 second. mg. Sir, mg sin 53 will act upwards only, right?
mg 20
mg sin
cos
53.
20 cos 53, 20 sin that 53 will be
Yeah,
upward.
act upwards. Okay. So you get
Sir,
mg.
140 minus mg sin 53.
sin 53 मालूम है ना?
So 4 by Farad.
हाँ.
Sir, after normal, what do we do?
What?
After we find normal, what do we do?
Friction.
No, we have to find work done by the changing kinetic energy, right? So what is the force acting on it? Work done by friction plus
So
work done by normal action plus work done by mg plus work done by external force, right? External force also I'm giving, right? कितना दे रहा हूँ? 20 newton दे रहा हूँ. Is equal to changing kinetic energy. This one we want to find, right? So work done by normal action is how much? Normal and
124
displacement.
into 2.
No, 0 है. Oh, ऊपर and displacement
Then
is 7. And work done by mg is also
mg
0.
is also 0.
0.
So what done by friction calculate karo. What is the formula? Force and displacement, right? So minus fk times of displacement is s.
Oh, okay, fine. Yeah.
Last में सब करेंगे 2 meters बोल के. Next plus what done by f कितना है? Force कितना है? इधर 20 cos. Force is how much? X direction में 20 cos 53 times displacement is equal to changing kinetic energy, right? And इधर क्या आएगा? Minus mu k times of n displacement plus 20 cos 53 times displacement is equal to changing kinetic energy.
Sir, won't force done by friction be minus mu and minus mu into n?
Minus
Into-
mu n minus
Oh,
see we done work done में force and displacement are in opposite direction minus fs लगा है. So f के जगह में mu k times of n. So if you calculate, so tell answer.
so you get minus 32.
And here you forgot about this one normal action calculations. You have to use this also, right? F sin 53 be लेने का, right? F cos
Yeah.
53, F sin 53.
So I'll give a guess, sir. Wait.
So
So you get minus
yes.
32.
So see, sir, answer will be negative for sure. No, sir, don't tell it, sir.
Don't see.
But I saw, sir. It's okay, no problem.
So minus 7 joules is the answer if you substitute all the values. Okay.
Okay.
So by this your work
Sir,
energy theorem.
Sir, what is normal?
Normal action can tell me if you take the
120
component
newtons, I think.
n plus 20 sin 53 is equal to mg. So n is
Oh.
equal to mg minus 20 sin 53.
Sir, how much will that be?
Calculate करो. M is 14,
Oh, sir,
140.
120 only.
Minus 20 into sin 53 is 4 by 5, right?
Sir, how 120?
नहीं, नहीं.
So
Oh,
124.
yeah, I'll be.
Sir, I'm
Oh.
getting 124, and then sir, delta K is coming as 8 into 31 by 3, which is 248 by 3.
If you substitute, you'll get minus 7 joules.
No, sir.
नीति करो. Calculation part में
Oh,
क्या कर रहे हैं?
sir.
देखो, ये कितना का 4 16 राइट 16 के सेपरेट किया तो कितना आएगा 124 राइट नो सब्स्टिट्यूट हियर minus mu k is how much minus mu k is 1 by 8 times n is 124 into displacement is 2 meters plus 20 into cos of 53 is how much 3 by 5 3 by 5 into displacement is 2 is equal to change again. Now calculate. 2 4 is 8, 4 3 is 12, 4 1 is 4. Minus 31 plus 5 4 is 20. 4 into
Sir, how
3 12,
31? Sir,
24.
31 by 2, no, sir.
2 4 is 8, right? 4
Sir,
table will go. Right? 4
32.
3 2 4 1 is 4 31. अरे 2 table में 2 4 is 8, right? No, 4 table
Sir,
जाएगा ना.
where did the 2 come from, sir?
Displacement. Work done you are not calculating. Force into displacement, force into displacement. Displacement is 2.
Yeah.
See, ये समझ में सब समझ में है ना ये सब
हाँ.
समझ में आया सब
Yeah, sir.
म्यू के जगह में आई सब्स्टिट्यूट 1 by 8
Okay.
n के जगह में आई सब्स्टिट्यूट 124 डिस्प्लेसमेंट के जगह में हाउ मच आई सब्स्टिट्यूट
2.
हाँ मतलब वो 2 उधर ही आ रहा है ना सो इट इज हाउ मच -7 आया हैप्पी
Yes, sir.
so our work energy theorem done.